Hello, everyone. We're the Half Dozen, also Group 2. And for our final project, we pursued the Dayhawk toy plane launcher. My name is Cody Arbizo.
My name is Eric Barrientos.
I'm Preston Chavez.
Connor Green.
And I'm Maurice Guillet. Okay, so here we have the background, and why we chose this project is because throughout our childhood, we were all fans of planes, and we're all intrigued with the history of aircraft. And why we take up this project, us, the Half Dozen, is because we wanted to create the toy that we all would have wanted when we were kids.
So, what makes our product different? It holds educational value in the sense that children will grow up with it and play with it. They learn how gear reduction works while assembling. They can learn about 3D printing and just putting together our project. Beside that, you have people in the middle age that can collect this, and people like ourselves that are intrigued with aviation who may want this in their closet. So, a little bit about the practicality. Like I said, it could be used as a toy, collectible, educational tool, easy to manufacture. We can do plain molds or injection molds that'll reduce the costs rather than us assembling it as well. You will send it unassembled and you'll put it together. It's designed so that a child can put it together and be easy to manufacture in the sense that you can 3D print it at home. Product is relatively cheap to manufacture. About 3 kilograms of material is $44.97. It's easy to put together and operate. You can ship it unassembled, and that'll drive the cost down. And there's also possibility of us selling STL files for you to print out at home and put it together yourself. Here are some of the assembly drawings, so I'll let Preston take it away.
So this is page 1 of the full Dayhawk plane launcher assembly. In the top right, we have a shaded isometric view. Then on the bottom of it, we have the front view, and then a section view cutting through the entire assembly, and with the correct part balloons attached to each component. And then this is page 2 of the full Dayhawk plane toy launcher assembly. We have the bill of materials, or other known as the part list. We have the item number of each component. We have the part name, the material, and the quantities of the components. And generally, our most common material is PLA plastic. This is the ramp for our plane launcher. It's a fairly simple design, so that way we're cutting costs on the complexity on our end. But at the same time, there is a leveling mechanism that's very similar to the weight adjustment ability of a gym machine, where there's a vertical array of holes, and you can take out a pin at the bottom right corner and readjust the pin to your desired height. This is the toy plane itself, composed of 3 parts: the upper component of the plane body, the lower component of the plane body, and then the centerpiece, which is the wings, or wing plural because it's one piece. And the 2 parts of the body connect with a clutch power mechanism similar to that of Legos. This is the rotary subassembly, which goes at the base of the plane launcher. This is what creates the rotational ability of the launcher. And on the inside, it is powered by a crank, a spur gear, a worm gear, and an internal spur gear. And then this is the runway subassembly, composed of primarily a base and a lid. In the base, there is a rail, and that is for the slider to attach to. Also in the base, there are 2 ejected pegs, and the slider, which goes to the back, will be attached with a rubber band, and the rubber band will hold tension in between the two pegs in the back of the slider, creating kinetic energy potential for the flight of the plane. And now for the individual drawings.
So I was given free reign over the design of the actual ramp assembly. I did have some trouble coming up with a good design for the ramp. I think the difficult part for me was trying to figure something out that wouldn't need external parts such as hinges, bearings. And the reason I didn't want those things was because I wanted to avoid having to increase the cost of the product, which would affect the profit margins. Additionally, one of our ideas was to sell this on as a separate STL file, like on a website such as Printables. The ramp has 3 positions it could adjust to by using a 3D printed pin to lock the chosen setting in place. I think this was a pretty simple but yet effective design for the ramp. There's also visual representation of how it works in an upcoming render video. To talk about the actual drawings, it's made up of 4 separate pieces. So the first part is the ramp base, and then in the next slide it shows the ramp cylinder, which is a hinge for the ramp to pivot up and down. And the next one is the locking pin that I was talking about earlier. And then this is the ramp piece. And then at the bottom of the ramp, there's a hole that goes onto the base where the pin it passes through both of them to lock.
And this is the upper body component of the plane. The geometry is quite complex, given that it was based off of the initial design of the F-117 Nighthawk. And since the geometry was unconventional to dimension in its entirety, I have created some compromising but also more conventional injection mold components. And this is the bottom half of the plane body. And then this is the upper half of the top part injection mold. This is the upper part of the bottom half injection mold. This is the lower part of the top half injection mold. And this is also the lower half of the bottom part injection mold. And then this is the plane wing. And since the plane wing was designed to be cut from foam board, all the dimensions are taken from an adjacent datum in the bottom left corner.
And for the subassembly of the very bottom subassembly, the one that everything will sit on top of as the product is up as a whole, this is the base plate of that, which is the very bottom piece, the main bottom piece of that, other than the legs it stands on top of. And you can see there's holes in there for each of the cylinders and the legs on the side. And this is the base plate of that. And one of the inside pieces as well is going to be this internal spur gear. And as that's in there, we have these on the outside. These 3 of these are going to be the legs of this subassembly. Will help hold it up in the 3 holes we saw a couple slides back. The foot brackets is what we call it. And this is a spur gear that we have on the inside of the total subassembly. And as this whole subassembly will help rotate the ramp, this is one of the gears that will help do that. As more part of the internal mechanisms of this subassembly, we have this drive gear shaft and this center shaft. And to top it all off, literally, is the lid plate of the whole subassembly of this base subassembly. And it'll just cover up everything on the inside, all the gears with the pieces that are going to be used to rotate the ramp. And that's it for that subassembly.
Okay, so here we have the first part of the launch mechanism subassembly, and this is the hook. This is what the plane will connect to. The hook can adjust the angle in which the plane will take off from the ramp. Here is the launch mechanism base, and as you can see, there is a rail in which a sliding piece will slide through, and there will be two pegs in which a rubber band will wrap around, and the rubber band will also wrap around the sliding piece. So the rubber band that will launch the sliding piece will catch onto these pegs and launch the plane forward. Here is the cover to cover everything that's internal with the launch mechanism and to make the ramp look simpler and more aesthetically pleasing. And here is the sliding piece in which we'll slide through the rail and the cover. The middle section in the middle drawing is the part in which the rubber band will wrap around.
All right, and for the subassemblies, we have renders of that ramp subassembly and the launch mechanism subassembly, and the one for what rotates the ramp. Start with the ramp itself. Of course, what's hidden is the pegs that will help raise the ramp or lower it, the peg holes, and you can see that cylinder that is there that can change the height of that ramp. And we can see more of what's inside for this assembly. The launch mechanism one. You see all the screws, like the four on top that'll hold the lid on top, and a few on the inside there that will help keep other things together. Also on the inside is the two pegs near the right side, as we can see, that the rubber band will go around. And as Preston said, you can see the hook on top of the slider. The hook will go into the slider, and the slider in through that hole on the right side to the back. As the slider is released, the hook will be moved with it, which the plane will sit on top of, and then the plane will launch off the ramp. And then this is the base subassembly, what rotates the ramp. And you can see as the ramp will sit on top, to rotate it manually, you can see the white mechanism on the left side. You can twist it, and it will use the gears on the inside to rotate the ramp. We have here an animating video of the product. Here is the animation of the rotary specific part.
Here's a little bit more about our design process. So once we got all of the technical stuff, we had some extra time. So we want to create some graphics and textures for our plane. So on the left is a pattern that was inspired by, Mesa camo as well as the Van Halen guitar. And then on the right side, we have a decal that is inspired by Kill Bill. If you have seen the film, this is kind of the color scheme the main character wears throughout. So our design process was very democratic. All of us had equal say and equal vote in whatever we were deciding. We also were very good at critiquing one another. None of us took it too serious, and we were able to kind of build off of each other and create a great project. We prioritized fast communication, so we used a Discord server, and we were very specific about channels. And I think we have 15 channels just for different parts of our project. So the biggest thing is we want to simplify the design so a child can build it and it would be easy to manufacture.
All right, and describe in total how we did this whole project and the timeline. We have the most of the Gantt chart that you'll be able to see without it being harder to see. And in the bottom right, of course, just a render of the bottom subassembly. And in total, the Gantt chart had mostly meetings, meeting minutes, when we did assignments, and when we did things like this, the live presentation, and other specific things like getting team shirts and 3D printing parts. All right.
As for the closing remarks, we believe we produce a unique and educational product for children and aviation enthusiasts alike. And any questions? No questions? Here's our table of figures. Thank you.